At this point, we're discussing an improper integral as we're approaching essentially a discontinuity or an asymptote. If our function is not continuous as we approach b, then we need to set up the limit as c approaches b from the left side. And we're approaching from the left side because of our interval. That's why we have that little negative up there as a superscript within our limit. And that's of a to c. And typically I'll actually use a b, but I can't have multiple b's within the same problem. Of f of x dx. If it's a lower bound, we'll approach a if it's a discontinuous point from the right side. Again, that's why there's a plus sign there as a superscript within our limit. And that's if c approaches a from the right. And then if both points are discontinuous, we'll have to break this up into two and then use steps A and B. This is little notebook worthy. Make sure you get that down. Make sure you ask questions if you have them. We're going to now go work a few problems with this. If you consider something divided by x, 0 is a discontinuity. Therefore, we need to set up a limit as a approaches 0, and we'll approach 0 from the right. And this would be of a to 1 of x to the negative 1/3 dx. At this point, we're set up to integrate, so we're going to take the limit as a approaches 0 from the right of, and that'll go to 2/3 x, 3/2 x to the 2/3 on the interval a to 1. At this point, we use the fundamental theorem. A is approaching 0 from the right still, of 3/2 of 1 to the 2/3 power minus 3/2 of a to the 2/3 power. As a approaches 0, our piece there approaches 0, therefore we're going to 3/2. Therefore, we know that the integral from 0 to 1 of dx over the cube root of x converges to 3/2. This is a point where a lot of students will make a mistake. They won't set up the limit piece, even though it is a discontinuity. If you don't do this, the AP board will not award you your points for the final answer. You really do need to set up the limit within this. So make sure that you're being conscientious of discontinuities within your definite integrals from here on out. Again, with this example, we have a discontinuity at 0. We need to set up the limit as a approaches 0 from the right. This is of the integral from a to 2 of x to the negative 3rd dx. The integral would give us negative 1/2 x to the negative 2nd along our bounds a to 2. At this point, we should use our fundamental theorem. And that's a negative 1 over 2x squared, and x is 2, minus a negative. A is approaching 0 from the right. I am going to use a value that's pretty close, so 0.000001. Let's consider taking that and squaring it. In your denominator, you're dividing by a super large fraction, which when you keep change flip, that's going to approach infinity. And something rather small plus infinity gives you an infinite value, comma does not exist. Therefore, we know that the integral from 0 to 2 of 1 over x cubed dx diverges because we get infinity for our final answer. I'm going to go ahead and split this video, then we're going to work a few more examples. Thank you. Make sure you reach out to me if you have any questions. I do appreciate it.